Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for May-June 2023, and the code is 9709/31. Okay, so let's move on to question number 1. So for question number 1, solve the equation 3e2x minus 4e negative 2x equals to 5 and give the answer equal to 3 decimal places. So first of all, I will copy the equation. Okay, now by looking at the second term on the left hand side, there is e negative 2x. So to eliminate this e negative 2x, we need to multiply by e 2x. Alright, so times e 2x. So e2x multiplied with 3e2x minus 4e negative 2x, that equals to e2x multiplied with 5. Okay, next step is going to be the expansion. So now, to solve the expansion, our formula is EA times EB equals to E of A plus B. Alright, so I'm going to apply this formula to simplify it. So first is e2x multiplied with 3e2x. So you will be getting 3. Then the e2x multiplied with e2x, it will be e2x plus 2x according to the formula. That means I'm getting e4x. Alright, so e4x. Then the next is the multiplication of e2x and negative 4e negative 2x, which means now e2x multiplied with e negative 2x, it becomes e2x plus negative 2x. So which means it will be e0. So e0 is basically 1. Okay, so which means I will be getting minus 4 for my second term. Then for my right hand side, it will be 5e2x. Alright, so from here we will rearrange. So I will move the 5e2x to the left hand side. So 3e4x minus 5e2x minus 4 equals to 0. So from here I notice that e4x is basically square of e2x, right? According to another formula. So e a to the power of b, it will be same as e a times b. Alright, so from here I will just write 3e 2x squared, right, which is my e4x as well, minus 5e2x minus 4 equals to 0. So from here, it is a quadratic equation in terms of e2x, right? This is your original x. I mean, this is your, when you compare to the quadratic equation, so which is ax squared plus bx plus c. That means now your x becomes e2x. So this e2x squared will be the x squared. Okay, so from here I will be using the quadratic formula, which is a equals to 3, right? B equals to minus 5, c equals to negative 4, and I will, instead of writing x equals to minus b plus minus square root, so I will write e2x now, because now my x has been changed to e2x. So it is minus b is minus 5, plus minus square root of b squared. So b squared is minus 5 squared, minus 4, a is 3, then the c is minus 4, over 2a. So my a is 3. Alright, so I'm using this quadratic formula. So ax squared plus bx plus c equals to 0. Therefore, your x is minus b plus minus square root b squared minus 4ac over 2a. Alright, so when you solve this, you will get 5 plus minus square root of 73 over 6. So from here, we need to get decimal place. So it will be negative 0.5907, and another one is 2.2573. Okay, so here I give more decimal places because this is just the working. Now, for your information, exponential graph. Okay, so by looking at the exponential graph, this is your EX graph. Right? So here is 1. It is always above the x-axis, which means your e2x, your EX is always greater than 0. Same for the e2x. So e2x must be greater than 0 as well, which means e2x equals to negative is undefined. Okay, so you can just write down e2x will be more than 0. Therefore, your e2x will be just one value, 2.2573. Okay, so from here, you need to solve the equation, which means you need to find what is the x. What is the x? Alright, correct to 3 decimal places. So, which means now, e2x equals to 2.2573. So, to eliminate the e, we are taking ln both sides. So, 2x will be ln of 2.2573. And hence, your x is going to be half of ln 2.2573. Now you use calculator and get the answer correct to 3 decimal places. That is going to be 0.407. So this is the solution for number 1. Okay, so now let's move on to question number 2. Question 2a, sketch a graph of y equals to modulus 2x plus 3. So to sketch the modulus graph, first of all, I will just ignore the modulus sign. Okay, so let y equals to 2x plus 3. So then to sketch this straight line, I need to find 2 points. Where x equals to 0, my y is 2 times 0 plus 3, which is 3. And then y equals to 0, 0 is 2x plus 3, which means my x is going to be negative 3 over 2. So now I found 2 points. So points equals to 0, 3 and negative 3 over 2, comma 0. Okay, so now we can just simply sketch this graph. So my x will be 0 and negative 3 over 2. Let's say here is minus 1, minus 2, minus 3. Then here is 1, 2, and 3 for my y-axis. Okay, so first point is 0, 3. So 0, 3 means x is 0, y is 3. The second point is negative 3 over 2 and 0. Negative 3 over 2 is basically negative 1.5. So negative 1.50 is somewhere here. Now when we sketch a graph, right, just for information, this is the straight line. So please sketch using ruler. Okay, my graph is not really accurate. Alright, so supposedly when you are sketching y equals to 2x plus 3, you should have the dotted line over here. Alright, this is a complete graph. But then because of the modulus, so look at the modulus here. So the modulus means that there is no negative for the y value. It must be positive, which means we have to reflect this dotted line by referring to the x-axis. Okay, so it means that it will be reflected to this. Alright, so this will be your modulus graph. Okay, so done the sketch. Right? So if you want, you can label this as negative 3 over 2. Okay, so 2a is done. It's solved. Now, B, solve the inequality 3x plus 8 greater than modulus of 2x plus 3. So since we have sketched modulus of 2x plus 3, okay, then we can just use a graph to solve this question. So now what I need to do is I will just find out what are the points from 3x plus 8 so that I can get the idea from the graph. So when y equals to 3x plus 8, right, when your x equals to 0, your y is 8. Your y equals to 0, your x will be negative 8 over 3. Okay, so now I get the idea, 0, 8. So 0, 8 is somewhere here. Let's say for example. Then another point is negative 8 over 3 and 0. So negative 8 over 3 is basically less than negative 3 because if negative 3 will be negative 9 over 3. Okay, so somewhere here. So now if I sketch a graph, look at here. Right, this is my graph of 3x plus 8. So if you need to get the 3x plus 8 greater than modulus graph. Okay, by looking at the graph here, if this dotted line, the red dotted line, will be greater than the blue line, provided it is starting from this point, okay, this x, right? So it means that now I need to find the intersection between the green, the dotted line, and also the blue line. Now be careful with this, because you should understand that your original graph, okay, for the first part, the part A, your original graph, when we sketch y equals to 2x plus 3 without the modular sign, is supposed to be this blue dotted line. So this line, right, the graph which is less than -3/2, that means this part, it is a reflection of the dotted blue line, or the blue dotted lines in the x-axis, which means this equation is basically y equals to negative of 2x plus 3. Okay, and now we need to find the red intersection point, which is here, which means now this intersection point is the intersection points between y equals to negative 2x plus 3 and the red line, which is the new graph. Alright, so be careful with this. So now what I need to do here is I will just write for the intersection point, or no need to write this, then I will just write 3x plus 8 equals to negative of 2x plus 3, because I need to find the intersection point. Okay, so from here I will get 3x plus 8 equals to negative 2x minus 3. Then I can move the minus 2x to the left hand side, it becomes 5x, and then this plus 8 will be moved to the right side, becomes minus 11, which means now my x is negative 11/5. Okay, so I have found this red color is basically negative 11/5. Alright, so based on this graph, we know that as long as the x is greater than negative 11/5, the dotted line, the red dotted line, is always above the modulus graph, okay, which satisfies this inequality. So which means our final answer here will be x greater than negative 11/5. Okay, so this is how we solve it. We solve using graph. But of course, there's another idea to solve this question, which is using definition. Okay, so you have to use a definition of the modulus. But now, since first part is sketch graph, so the easiest way is just using the graph method to solve it. Alright, so maybe you can just label here as y equals to 3x plus 8. Okay, so that's the solution for part B. Now, question 3. Find the coefficients of x cubed. X cubed in the binomial expansion of 3 plus x multiplied with square root of 1 plus 4x. Okay, so 3 plus x multiplied with square root of 1 plus 4x. So the square root I can change to degree half first. So now when you look at the first bracket, or the first term, 3 plus x, is with degree 1, means that we don't need to do any expansion. Alright, and now I'm going to use the binomial expansion formula, which is 1 plus x to the power of n, because the degree is not positive integer. So you have to use this formula. It will be 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial times x cubed, then and so on. Alright, so I show you up to x cubed because you need to find coefficient of x cubed. So now when you compare, means that the first term you rewrite because we don't do any expansion, but the second term, degree half of 1 plus 4x, which means now your n is half. Okay, your x in the formula becomes 4x. So you just change accordingly. It will be 1 plus, the n is half, then 4x, plus half, then half minus 1 is negative half, after that over 2 factorial, 4x squared, plus half, half minus 1 is negative half, then half, the n minus 2, half minus 2, it becomes negative 3 over 2, over 3 factorial, then followed by 4x cubed. So I expand up to x cubed because you need to multiply with the 3 there. Alright, so then from here I will rewrite first and simplify the terms inside the square bracket. So the first term is 1, second term is 2x, third term it will be negative 2x squared. Okay, then the last term it will be plus 4x cubed. So then now, no need to do the full expansion because our constant is just the coefficient for x cubed. So in order to get x cubed, this 3 is a constant must multiply with the term with x cubed, which means I'm getting 12x cubed now. Okay, and for the x, it must be multiplied with the x squared in order to get x cubed. So I will get negative 2x cubed, and then write plus dot dot dot. Okay, so from here, I will be getting 10x cubed plus other terms. Alright, so from here, I will just write down my coefficient of x cubed equals to 10. Okay. Question 4. A. Show that the equation sine 2 theta plus cos 2 theta equals to 2 sine squared theta can be expressed in the form cos squared theta plus 2 sine theta cos theta minus 3 sine squared theta equals to 0. So instead of 2 theta now becomes 1 theta. Okay, so we need to copy the original equation first. Now we need to show that this can be expressed in just cos or sine of 1 theta. So now we need to apply the formula. Okay, just for your information, sine 2a is 2 sine a cos a. Then for the cos 2 theta or cos 2a, we have few formulas. Okay, so now by looking at the result here, you can say I can say that I want to change to cos squared a minus sine squared a, because basically we have 3 forms for this. The second form will be 2 cos squared a minus 1, then the last is 1 minus 2 sine squared a. Okay, so now to solve this question, the first term sine 2 theta you refer to sine 2a, which means now your a is the theta. Then I will get 2 sine theta cos theta. So here is my term, 2 sine theta cos theta. I found the second term in the result. Then here I have sine squared. This is my sine squared. But here is only 2 sine squared. I need to get 3 sine squared later on, which means, right, for the cos 2 theta, I must refer to the first form because I need to get cos squared and another sine squared, right? So plus cos squared theta minus sine squared theta from the cos 2 theta. Then right hand side, I will just move it to the left hand side, becomes negative 2 sine squared theta equals to 0. Okay, so now I just need to rearrange. The cos squared theta, right, will be written first, then followed by 2 sine theta cos theta, and then the sine squared minus sine squared theta minus 2 sine squared theta will be our negative 3 sine squared theta. That equals to 0. Alright, so this is how we show. Okay, so done for the 4a. Now b, hence means use the previous answer. Solve the equation sine 2 theta plus cos 2 theta is 2 sine squared theta. These 3 terms are exactly the same as the previous form. Okay, that means I can just change it to cos squared and sine squared. So now sine 2 theta plus cos 2 theta is 2 sine squared theta. I will simply change it to cos squared theta plus 2 sine theta cos theta minus 3 sine squared theta equals to 0. Okay, we have proven it in the part A. Now we need to solve this for 0 to 180 degrees. Okay, so when you need to solve this question, basically we have 2 methods. The first one is you can change all to tangent, right? So if I need to get tangent, tangent is sine theta over tangent theta is sine theta over cos theta, which means now by looking at the sine squared theta here means that I have to divide by cos squared theta. Okay, so when I divide the whole equation by cos squared theta, let me show you step by step. Alright, so from here I will simplify. The first term becomes 1. Cos squared theta over cos squared theta is 1. Then for the second term, the cos theta from the numerator can be cancelled off first, then left another cos theta in the denominator. So end up with 2 sine theta over cos theta, which is our 2 tangent theta. Okay, so for the last term, it will be negative 3 tangent squared theta equals to 0. Now I need to rearrange this first to get quadratic equation. So it will be 3 tangent squared theta minus 2 tangent theta minus 1 equals to 0. Okay, so from here you can factorize this into 2 linear factors, but then it will be in terms of tangent theta. So now I will get tangent theta minus 1 multiply with 3 tangent theta minus 1 equals to 0. So from here, if the multiplication of 2 terms equals to 0 means that one of the terms must be 0. So I will say tangent theta minus 1 equals to 0, or 3 tangent theta minus 1 equals to 0. Hence my tangent theta is 1, or my tangent theta is 1 over 3. Okay, so by looking at this domain, theta from 0 to 180 degrees. So since your tangent theta are both positive, means that they will be in the first quadrant. Okay, so now use your calculator. Theta is inverse tangent 1. Inverse tangent 1 is basically 45 degrees. Okay, so here is going to be 45 degrees, and another one is going to be 100. Okay, let me check my expansion. This is my factorization. So it's 3 tangent theta, 3 tangent squared minus 1 minus 1. So here it becomes minus 4. So it's supposed to be okay, here it's supposed to be plus 1 when you do that when you do the factorization. Alright, so tangent times 3 tangent is 3 tangent squared theta. Tangent times plus 1 is positive tangent theta, and then here minus 3 tangent theta becomes negative 2 tangent theta. Then minus 1 times plus 1 is minus 1. So there's a mistake here. This is minus 1 over 3. Okay. So then here is going to be negative 1 over 3. Since the tangent is negative, means that it will be in the second quadrant. Alright. So then when you use a calculator, theta is inverse tangent 1 over 3, you will get 18.4 over here. Our angle is the major angle, which means now your angle is going to be, alright, so I will show you step by step. So this theta is going to be 180 minus 18.4. Okay, therefore it will be 161.6. So you can just write that at last your theta is going to be 45 degrees and 161.6 degrees. So this is the working when you solve using first method, which means you divide the whole equation by cos squared theta. So as I mentioned just now, we have 2 methods to solve this question. Alright, so now I'm going to show you the second method to solve this. So second method is basically using the factorization. Okay, so let me check. Alright, maybe I will just show you here. Now, the second method, this is a second method. I will just rewrite first cos squared theta plus 2 sine theta cos theta minus 3 sine squared theta equals to 0. So you can factorize because you have cos squared and sine squared. Then the middle term has sine and cos. So when you factorize, it's like cos theta times cos theta. It will be cos squared. Okay. Then here, 3 sine squared theta and negative 3 sine squared theta, it will be 3 sine theta and then sine theta. Right? So which one is minus? I will need to get, you see here, plus times minus, it will be minus. Means now it is the major angle at the plus for 2. So for here is plus, this is minus. So then now you just do factorization. I will get cos theta minus sin theta, then cos theta plus 3 sin theta equals to 0. So you can double check by expanding all the terms. So cos theta times cos theta, cos squared theta, cos theta times 3 sin theta, it will be positive 3 sin cos. Then here is minus 1 sin cos, therefore you get plus 2 sin cos. Okay, then at last, negative sin theta multiplied by 3 sin theta, it will be negative 3 sin squared theta. So this is the expansion in terms of sin and cos. So then cos theta minus sin theta equals to 0, or cos theta plus 3 sin theta equals to 0. Okay, so from here, when cos theta minus sin theta equals to 0 means that cos theta is sin theta, then now you can just divide both sides by cos theta, which means 1 equals to tangent theta. Okay, so for the second term is still the same. I will just write cos theta is negative 3 sin theta, then both divided by cos theta. So I will get 1 equals to negative 3 tangent theta. Therefore, tangent theta is negative 1 over 3. So when you compare, right, basically I'm getting here tangent theta is 1, here 1 is tangent theta. And then tangent theta is negative 1 over 3, tangent theta is negative 1 over 3. So we are getting the same answer, okay, or same steps here. So these are the two methods to solve this question. Okay, but of course, if you use the second method, then you have to proceed with all of this, right? So your theta will be 45 degrees and the other one is 161.6 degrees. Okay, so that's all for this question. Now, question number 5. The equation of a curve is x squared y, so x squared y minus ay squared equals to 4a cubed, where a is non-zero constant. Part A, show that dy dx is this expression. Okay, so when you need to solve this, we need to use the products rule because you have x and y for the first term. So just a recall, products rule means d over dx uv equals to u v prime plus v u prime. Okay, so it's like you keep the u differentiate v and keep the v differentiate u. So now I'm going to differentiate using products rule. So keep the x squared, differentiate y with respect to x. Okay, so another formula here. When you need to differentiate a function of y with respect to x, which means you have to differentiate the function of y with respect to y first, then you multiply by dy over dx. Okay, so which means now I need to differentiate y with respect to y, which is 1, then I multiply with dy dx according to this implicit differentiation. Then plus, now keep the y because I need to keep the v, so keep the y, differentiate x squared, it will be 2x. Alright, so we get all these terms when we just solve the x squared y, when we just differentiate the x squared y. Now there's a minus a here. Remember the a is a constant, alright? So just keep it. So minus a, differentiate y squared, use back the same formula. Differentiate y squared with respect to y, it will be 2y. Then you multiply with dy over dx. Then for the right hand side, since the a is constant, when differentiate constant with respect to x, it will be 0. Okay, so from here I will write x squared dy over dx plus 2xy minus 2ay dy over dx equals to 0. Okay, now in order to get this, I need to get the dy dx as a subject. So dy over dx bracket x squared minus 2ay. Okay, and I move this 2xy to the other side, so it becomes negative 2xy. And then my dy dx equals to negative 2xy divided by x squared minus 2ay. But when you look at the answer here, it is positive 2xy. So what to do is factorize the negative from the denominator. So once you factorize negative from denominator, it becomes 2ay minus x squared. Okay, then the minus can be cancelled off. Alright, so that is our dy over dx. Alright, so now move on to B. Hence, find the coordinates of the points where the tangent to the curve is parallel to y-axis. Okay, just for information, if let's say this is a graph, the tangent is parallel to x-axis, that means the dy dx equals to 0. So it's parallel if tangent is parallel to x-axis, means dy dx equals to 0. But now it's mentioned that the tangent is parallel to y-axis. So when it is parallel to y-axis, okay, so when you look at here, this is dy dx equals to 0. And it will be perpendicular to, the purple line is perpendicular to the blue line, which means for the tangent which is parallel to y-axis, right, your dy dx is going to be infinity. Okay, so now by looking at the dy dx here, your dy dx is 2xy over 2ay minus x squared. So now from here, I will rewrite my dy dx first. It is 2xy over y squared minus 2ax. Wait, let me check. 2ay minus x squared. 2ay minus x squared. Okay, so since tangent is parallel to y-axis, which means dy dx equals to infinity, but we will not write infinity. So we know that infinity happens when it is a number divided by 0. Okay, which means now I need to let the denominator be 0. So 2ay minus x squared equals to 0. So if let's say the tangent is parallel to x-axis, means that the numerator equals to 0. Alright? And now you need to find the coordinates of the points. So from here, 2ay equals to x squared. 2ay minus x squared equals to 0. So from here, I will let this be x squared equals to 2ay. Let it be first equation. And now the points will be on the curve. Okay, so let's look at the curve. The curve has x squared y minus ay squared equals to 4x cubed. So I will rewrite this equation. X squared y minus ay squared equals to 4x cubed. This is the curve equation. Okay, I will let this be second equation. So now I will substitute the first equation into second equation because I have found the x squared. So now first into second. So I will get 2ay multiplied with y minus ay squared equals to 4a cubed. Okay, do the expansion. So first term will be 2ay squared, then minus ay squared equals to 4a cubed. So for the left hand side, you will get ay squared equals to 4a cubed. And now we need to find coordinates of the points, means that we need to find x and y values. Now, since your a is a non-zero constant, then I can just cancel off the a from both sides. That means right hand side still have degree 2. Then I will get y squared is 4a squared. So when y squared equals to 4a squared means that y is plus minus square roots of 4a squared, which means you are getting plus minus 2a. Okay, so let's check the conditions of the a first. So the a is just non-zero constant. It can be positive or negative. And also you look at the question, this is points, means you will get more than 1 point. Okay, so now from first equation, okay, we need to find the x coordinates now. So from first equation, when our y is 2a, the x squared becomes 2a, the y will be replaced by 2a. So from here I will get x squared equals to 4a squared. Therefore, my x is going to be plus minus 2a. Okay, so then when y equals to negative 2a, which is here, my x squared is going to be 2ay. Okay, then now I'm getting negative 4a squared. So x squared equals to negative 4a squared is undefined, right? Because x squared is always positive. And a squared is also positive already. So impossible to get a negative here. So which means you don't get any x when the y is negative 2a. So this is undefined. Right? So or probably I will just explain. A squared more than 0. X squared should be more than 0. Right? So x squared cannot be negative 4a squared. Therefore, this is undefined. Right? So from here, I will only get 2 points. So both points from y equals to 2a. So the points equals to x equals to 2a, y equals to 2a, and x equals to negative 2a, your y is also 2a. Okay, so these are the coordinates of the points when the tangent is parallel to the y-axis. Okay, now question 6. Relative to the origin O, the points A, B, C have position vectors given by OA, OB, OC. The quadrilateral ABCD is a parallelogram. Okay, now parallelogram means, let's say, for example, this is A, B, C, D. Parallelogram means that they are parallel to each other. Okay, these two sides, the opposite sides are parallel to each other. So now from here, to get the OD, this position vector of D is OD. What is your OD now? I can use vector AB equals to vector DC. You can use vector AD equals to vector BC. No problem. Okay, so I will start with vector AB equals to vector DC. So vector AB is found using OB minus OA. Then vector DC can be found using OC minus OD. Okay, now we need to find what is the OD. So get the OD as a subject by moving this negative OD to the left hand side. It becomes positive OD. Therefore, the OB and OA on the left hand side will be moved to the right side. It becomes OC minus OB plus OA. That will be my OD. Okay, so now replace all the three vectors. OC is 3, negative 2, negative 4. Minus OB is 432 plus OA is 213. Okay, so now simplify the x coordinates. So 3 minus 4 is minus 1. Minus 1 plus 2 becomes 3. Then minus 2 minus 3 minus 5. Minus 5 plus 1 is minus 4. Last coordinate minus 4 minus 2 will be minus 6. Minus 6 plus 3 minus 3. Okay, so let me check one more time. 3 minus 4 is minus 1. Minus 1 plus 2. Okay, the first one is 1. Alright, so therefore this is our OD. Okay, Okay, now B, the angle BA and BC is theta. Find the exact value of cos theta. Okay, where is our BA, BC? The angle between BA is here, BA and BC. So that means this is the theta, right? So when you look at the previous diagram, right? So now from the scalar product formula, we need vector BA and vector BC in order to get the theta, right? So I have to find BA, BC first. BA and BC. So BA is OA minus OB. BC is OC minus OB. So now my OA, 213 minus OB, 432 okay, and then BC is OC minus OB. Where's my OC? 3 minus 2 minus 4. OB is 432. So here I will get 3 minus 4 or 2 minus 4 is minus 2. 1 minus 3 is minus 2. The other one is 1. And then here is going to be 3 minus 4 is minus 1. Minus 2 minus 3 minus 5. Minus 4 minus 2 is minus 6. Okay, so now use the formula BA dot BC. This is a scalar products formula. Is magnitude BA, magnitude BC, cos theta. And now you need to find exact value of cos theta. Okay, so when you multiply, right, the dots products means you multiply. So minus 2 times minus 1. Then the next is minus 2 times minus 5. Then you plus, always plus. So plus minus 2 times minus 5 plus lastly 1 times minus 6. That will be the scalar product equals to the modulus is negative 2 squared plus negative 2 squared plus 1 squared, and the next modulus is negative 1 squared plus negative 5 squared plus negative 6 squared. Okay, so when you calculate the left hand side, it's going to be 6. Then here is cos theta. Alright, then the first modulus is square root 9, which is 3. Then the next is square root 62. Okay, then cos theta. So from here, our cos theta is going to be, now, before I move, I can just simplify first. This is 3, this is 2. I can cancel off. So then I will direct get the answer, which is 2 over square root 62. Okay, that is my exact value of cos theta. Now, see, hence, find the area of ABCD, giving your answer in the form of P square root Q, where P and Q are integers. Okay, so let's look at the diagram, ABCD first. So just now we have found the cos theta here. And then now we need to find the area of this parallelogram. Alright, so from here I will say that this area of parallelogram is basically double of area for the triangle ABCD. Okay, it can be split into two triangles. Sorry, it is the double of area of the triangle ABC. Alright, so I times 2, then it will be the area of the ABCD. So now I will rewrite here. Okay, better I redraw, it'll be easier. So here is the data. This is A, B, C, D. Right? So from here, I know that. Now, for your information, this is the extra note. Let's say you have a triangle. Okay, here is A, B. This is a data. So area of triangle, it is same as half AB sine theta. Okay, just now we have found the cos. Alright, so what I need to do is I need to get what is my sine theta. So then you can just write from B, cos theta is 2 over square root 62. So from here I can just draw a triangle. Right, if here is 90 degrees, triangle, here is theta, because the purpose for me to do this is I need to get what is my sine theta. So cos theta is 2 over square root 62. Cos is adjacent over hypotenuse. So now my adjacent is here. This is the hypotenuse, which means my opposite side is going to be square root of 62 minus 2 squared. So it's going to be square root of 62 minus 4. Then you will get square root of 58. So now this is going to be square root of 58. Okay, so which means my sine theta is going to be square root of 58 opposite over hypotenuse over square root of 62. Okay, or I can just simplify to be square root of 58 over 62. There's my sine theta. Now, since my theta is over here, right, I have found the angle. And by using this formula, I need to know the length of AB and BC. Alright, so now from part B as well, the length of AB, which is the magnitude AB, right? AB is same as BA, which is 3. So magnitude of AB is 3. Then I need to know the magnitude of BC, which is the length of BC. And then the BC, which is here, second modulus, which is square root 62. So I will write square root 62. So this is from B as well. Okay, then now I can just use the formula, use the idea. Area of ABCD is basically double of area of triangle ABC. Okay, area of, right. Now, area of the triangle ABC is half magnitude AB AC sine theta. So half magnitude AB magnitude AC sine theta. So the half and 2 can be simplified. Magnitude AB is basically 3. Square root magnitude AC. Okay, wait. AB, BC, not AC. Okay, I wrote wrongly. This is BC. Right, AB, BC. So the magnitude BC is square root 62. And then the sine theta we have found here. Square root of 58 over 62. Okay, so from here, it becomes 3 square root 62. Then instead of combining both square root, I will split it into two different square root now, so that you can see clearly. Okay, so the square root 62 will be cancelled off. So at last, I will get 3 square root 58. Alright, so that's why it's mentioned here. You need to leave your answer in P root Q, P square root Q, where P and Q are integers. So this will be the simplest form of the answer. Okay, now next question. The variables x and y satisfy the differential equation cos 2x dy dx. So let me copy this first. Cos 2x dy over dx equals to 4 tangent 2x over sine squared 3y, where x between 0 and pi over 4 is given that y equals to 0, x equals to pi over 6. Now, solve the differential equation to obtain the values of x when y equals to pi over 6. What is the x? Okay, so it means that y equals to pi over 6. What is the x? This is a question. Give your answer correct to 3 decimal places for the x. So obviously this is differential equation. Then we need to solve this using separable variables, right? So my y should be on the left hand side, means that sine squared 3y dy equals to, this cos 2x will be moved down. So I will get 4 tangent 2x over cos 2x then dx. After that, integrate both sides. Okay, so for the right hand side, tangent 2x over cos 2x, we know that 1 over cos x is second x. Okay, and we are able to integrate tangent x second x. So it will be second x plus c. Okay, so for the right hand side, I'm going to change to second first. So here 4 second to x. Now for the left hand side, we are not able to integrate sine squared directly. So what to do is you need to change it to double angle formula. So cos 2a is 1 minus 2 sine squared a. So which means 2 sine squared a. So just move it to the left hand side, and then the cos will be moved to the right hand side. It will be 1 minus cos 2a. Okay, and now this is 1 sine squared. So now sine squared a will be half times 1 minus cos 2a. Now, when you compare, this is sine squared 3y, formula is sine squared a, which means my a is 3y, right? So I will get 2a will be 6y. So 2a becomes 6y. Okay, so by using this double angle formula, the left hand side I will change to half, right? Half, take out the half first, integrate 1 minus cos 2a. So my 2a is 6y. So minus cos 2y. 6y, sorry. 1 minus cos 6y dy. Okay, this is what you need to do before you do the integration. Now, we are able to integrate all the terms right now. So half remains. Integrate 1 dy, it will be y. Integrate negative cos is negative sign. So negative sign. Rewrite 6x or 6y. Then differentiate 6y, it will be over 6. For the right hand side, factorize the 4. Now when you integrate second, okay, this is not second, sorry, I missed out the tangent. Okay, should have another tangent. So tangent 2x, the over cos you change to second. Alright, this should be the correct form. Tangent 2x, second 2x. So now refer to this formula. Tangent x, second x, it will be second. So when I integrate tangent 2x, second 2x, it will be second 2x. But then when you differentiate 2x, it will be over 2. And both integration without limits, therefore you have to plus c. Okay, this will be my integration for both left and right side. Now, I can just simplify 2 and 4 becomes 2. Then here becomes half y minus sine 6y over 6 equals to 2 second 2x plus c. Okay, so next is to get the c by replacing the x equals to pi over 6 and y equals to 0. So when x equals to pi over 6, y equals to 0, left hand side half bracket 0 minus sine 0 over 6 equals to 2 second. Okay, now for second, I need to get the value, so I better change back to over. 1 over cos. So here becomes 2 over cos 2x. Then plus c. So sine 0 is 0. Right? This is 0. That means the left hand side is 0. 2 over 2 pi over 6 is basically pi over 3. So cos pi over 3 is half. Okay, which means now 0 equals to 4 plus c. So my c is negative 4. Now the question is asking for what is the x when y equals to pi over 6, and the x correct to 3 decimal places. So now we do not need to get the y as a subject, just substitute this c in the general form or in the general solution. So I will get half bracket y minus sine 6y over 6 equals to 2 second 2x minus 4. Okay, and now we need to get the x when y equals to pi over 6. So when y equals to pi over 6, half times pi over 6 minus, okay, now you see, pi over 6 times 6, it will be pi. So I will just write sine pi over 6 equals to, now we need to get x. So instead of writing second 2x, I will change to 2 over cos 2x, then minus 4. This will be better. So now I will get this half times pi over 6 is going to be pi over 12. For your information, sine pi is 0. Okay, so it means that the second term is going to be 0. Then now I will move this minus 4 to the other side. So it becomes plus 4 equals to 2 over cos 2x. Then now, before we get the x, you need to get the cos 2x first. So this cos 2x move up. This whole term, both terms on the left hand side will be moved down. So it becomes 2 over 4 plus pi over 12. Okay, and now use a calculator. This is going to be 0.4693. Alright, so now let's check. Your x is defined from 0 to pi over 4. Okay, your x is from 0 to pi over 4. So x, which means it is in the first quadrant. So now your 2x will be from 0 to pi over 2. Okay, this is the value. We only get one value here because of first quadrant. So now my 2x is inverse cos of 0.4963. That is 1.08230 radians. Remember, this is in radians. Alright, therefore your x is going to be 0.541. Right, so that's the solution of this question. Okay, so now let's move on to next question, which is question number 8. This number 8 is regarding the partial fractions. So now you are given fx is 3 minus 3x squared over 2x plus 1 multiplied with square of x plus 2. Express fx in partial fractions for parts A. So now 3 minus 3x squared over 2x plus 1 multiplied with square of x plus 2 is going to be a over 2x plus 1 because the denominator is a linear factor, 2x plus 1, the x with degree 1. But the second term, this is squared, right? So I will treat this as repeating factor. So when repeating factor, it will be degree 1 for the first factor and followed by degree 2 of the second factor. And when you look at the x plus 2, this is degree 1, which is a linear factor. Therefore, numerator will be constants b and c. Okay, this will be the partial fractions, the general form of partial fractions. Now, our purpose is to get the same denominator as in the left hand side. Okay, so what I need to do here is I multiply the 2x plus 1 with x plus 2 squared, because I need to get these two factors in the denominator. So then the numerator must be the same, so that you will be getting back the same rational function. So the second term is b over x plus 2. Now for x plus 2 I have degree 1 for the second factor. So I still need degree 1 for second factor and first factor. So I multiply with 2x plus 1, then x plus 2. Okay, also always compare to the left hand side to get the same denominator instead of using cross multiplication. So for the last term, it is square of x plus 2. So I already have this second factor. Now I need to multiply with 2x plus 1. Okay, so then I will rewrite the numerator, the left hand side. So in this step, you will realize that all the denominators are the same. Therefore, we can just cancel off all the denominators and just write down the numerators. So I will get 3 minus 3x squared equals to a times square of x plus 2, then plus b times 2x plus 1, after that x plus 2, plus c times 2x plus 1. Okay, so we need to find the three unknowns from this equation. Very simple, just let the factor be 0. Okay, let all the factors be 0. So firstly, I will refer to x plus 2. So let x plus 2 be 0. That means your x is minus 2. Alright, so then 3 minus 3 bracket negative 2 squared equals to, now whenever you see x plus 2, that means this whole term is 0. So 0 times a is 0. Therefore, we can skip the first term. Same for the second term. 2x plus, here, x plus 2 multiply with 2x plus 1 multiply with b. So the x plus 2 will be 0. So again, 0 times b, it will be 0. Then we can find the c directly. So it will be c bracket 2 bracket minus 2 plus 1. Okay, so for the left hand side, 3 minus 3 bracket minus 2 squared, it will be minus 9. Right hand side, 2 times minus 2 minus 4. Minus 4 plus 1 is minus 3. Therefore, my c is going to be 3. Right? So now the next is I will let the second factor be 0, which is 2x plus 1. So let 2x plus 1 be 0, which means our x is negative half. So now again, we replace the whole equation, all the x in the whole equation by negative half. So I will get 3 minus 3 times negative half squared equals to, now when you look at here, remember this 2x plus 1 is 0, this 2x plus 1 is 0, which means now you can find the a directly because the x plus 2 won't be 0. So I will get a bracket negative half plus 2 squared. So for the left hand side, you will get 9 over 4, and the right hand side, square of negative half plus 2 is going to be 9 over 4 as well. Therefore, my a is 1. Okay, so to find another unknown, we have found c and a. So now we need to find b. So to get a b, you just let x be any other values because we don't have other factors. So let x be 0. So when x equals to 0, my left hand side, 3 minus 3 bracket 0 squared equals to a. So now my a will be 1. Okay, I will direct change to 1. Then my x is 0. 0 plus 2 is 2. So 2 squared plus b is unknown. 2 times 0 plus 1 is 1. Then 0 plus 2 is 2 plus c. Okay, c is 3. Just replace it. Then 2 times 0 is 0. 0 plus 1 is 1. Okay, so now left hand side is 3. First term is 4. 2 squared is 4. then middle term is 2b, last term is 3. So I can cancel off both 3, then left hand side becomes 0. That means 2b equals to minus 4, which means my b is negative 2. Okay, so once you have found the a, b, c here, just need to rewrite your partial fractions, the general form. Then that will be your answer. So in order to get the answer, 3 minus 3x squared over 2x plus 1 multiplied with x plus 2 squared is going to be a. A is 1, so 1 over 2x plus 1. Then the b, so plus negative 2 over x plus 2. So, but then we never write plus and minus 2, plus and minus 2. So what we need to do is just direct multiply the plus with the minus. Just write the middle as minus. Okay, lastly, plus c. Right, hang on please. So the c is 3. Okay, so here is going to be plus 3 over x plus 2 squared. So that is our solution of this question. Alright, so with this we have done the partial fractions. Now b, hence find the exact value of this integration, giving your answer in the form of a plus b ln c, where a, b, c are integers. So now integrate 0 to 4 fx dx is integrate 0 to 4. Now this is your fx. Okay, so 1 over 2x plus 1 minus 2 over x plus 2 plus 3 over x plus 2 squared dx. Okay, so to integrate this, now I will split it into 3 integrations. So for your information, the first term, since the denominator with degree 1, we will have to use ln. Okay, so 0 to 4 for ln, just let you know that integrate f prime x over fx dx is ln of fx plus c. So it means that the numerator is a differentiation of denominator. So now when you look at the denominator now, 2x plus 1, so I will rewrite my denominator. When I differentiate 2x plus 1, it's supposed to be 2. Okay, but in order to get back 1 here, I need to times half outside. Right? So for second term, it's still the same because it's degree 1 for the x plus 2. So now minus integrate 0 to 4 over x plus 2 dx. When I differentiate x plus 2, it will be 1. So in order to get 2 from the original function or original rational function, I need to times another 2 outside. Alright, so for the third integration, now your degree is 2 in the denominator, means that we cannot use ln when we have to move up. So when I move up, I will write 3 integrate 0 to 4 x plus 2 to the power of negative 2 dx. Okay, so for your information, the last integration is going to be using this formula. Integrate degree n of ax plus b dx. It will be ax plus b to the power of n plus 1 over n plus 1. And then differentiate ax plus b is a, followed by plus c. Okay, so now the first integration is going to be half the whole integration here is going to be the ln already. So I will write ln of 2x plus 1. So I put a modulus sign here, the straight lines here, the modulus lines, to make sure that 2x plus 1 is positive. So if you are sure that 2x plus 1 is positive, then you can just ignore the modulus line. Okay, and since all of this integration share the same limits, 0 to 4, then I will combine it later on. Now for the second integration, it's going to be negative 2 ln of x plus 2. Okay, the third integration, you need to use this formula, the ax plus b to the power of n. So I will write 3, then x plus 2, degree minus 2, you plus 1 becomes minus 1 over negative 1, and differential x plus 2 is going to be 1. So these are my integrations. And now I will rearrange it. I will simplify it first, especially to simplify the last term. I just rewrite the first two terms. So now for the denominator of the last term, it is minus 1. So minus 1 times 3 is minus 3. Okay, but when you look at the degree of the brackets here, x plus 2, the degree is minus 1, so I will move it down. So it becomes over x plus 2 with degree 1. Then limits will be 0 to 4. Okay, so then now I will start replacing the x values. So firstly, the x will be replaced by 4. So I'll get half ln. So 2 times 4 is 8. 8 plus 1 is 9. Since this is positive, then I will ignore the modulus sign. Okay, then minus 2 ln. 4 plus 2 is going to be 6. Then minus 3 over 4 plus 2 is 6. I get these three terms when my x equals to 4. Then minus when the x equals to 0. So I get half ln 2 times 0 is 0. 0 plus 1 is going to be 1. Minus 2 ln 0 plus 2 is 2. Minus 3 over 0 plus 2 is 2. Alright. Now look at the question first. You need to leave your answer in a plus b ln c, where a, b, c are integers. So before we simplify, ln 1 is 0. Okay, simplify the ln 1 equals to 0 first. And then now I will write, okay, now look at the answer here. It will be b ln c. So it means that I need to combine all the ln. But then when you look at the ln here, the first term, the coefficient is half. Second term is minus 2. Then here is minus 2 before we multiply by the negative. So I better change all to squared. Alright, I move up. So now I will apply another formula. Ln a power b is going to be b ln a. So now you are given b ln a. You change to ln a power b. So I will write ln 9 to the power of half minus ln 6 squared minus, this is half. Then this minus times in, it will be plus 2 ln 2, it will be ln 2 squared. Then again minus is a plus, so plus 3 over 2. Okay, so now for the ln, again we need to simplify. Ln a plus ln b is ln ab. And then ln a minus ln b is going to be ln a over b. So from here, first term minus second term. Alright, so I will write equals to ln of 9 square. This is 9 power half means square root 9. Minus means over 6 squared, 36. Okay, or probably I just write 6 square. 6 square. And then here is plus. Plus is times. Times by 2 squared. This is my whole ln. Okay, then now minus half plus 3 over 2. That means it's plus 1. Alright. So when you look at the question here, the ln is the second term for your final answer. Means now I need to rearrange. So it will be 1 plus ln Okay, so this is basically 3, 2 squared is 4, then 6 squared is 36. So I will get 1 plus ln. This is going to be 1 over 3. Okay, so here 1, here 12. Then 1 over 3. But then the answer here, when you look at the answer here, it is a plus b ln c. C is an integer. It's not a fraction. So it means that you cannot leave your answer in this form. What to do is, right, we have a formula. Ln a to the power b is b ln a, right? Therefore, 1 plus this 1 over 3 is basically ln 3 power negative 1. So this negative 1 will be moved down. So I will get 1 minus ln 3. Okay, this is the first option. Second option is after this, you can just write 1 plus, then you split because it's division. So ln 1 minus ln 3. So ln 1 is 0. That's why you are getting 1 minus ln 3. It's the same answer. Okay, so that's all for the working of this question. So your answer is 1 minus ln 3. Alright, so now let's move on to question number 9. The constant a is such that this integration is 1 over 8. Show that a equals to half ln 4a plus 2. So integrate 0 to a, x e minus 2x dx equals to 8, equals to 1 over 8. Okay, so what I need to do here is to integrate these two terms. It is going to be integration by parts. Okay, so I will let u equals to x. dv dx is e negative 2x. So now your du dx, it will be 1. V is integrate exponential negative 2x. You rewrite the whole exponential. Then divide by differentiation of negative 2x. It will be negative 2. Okay, now for your information, the integration by parts is integrate u dv over dx is going to be uv minus integrate v du over dx. This is a formula without limits. So when you are given limits ab, add on the limits for the right hand side. Okay, so now I'm going to apply this by parts formula in solving the integration. So my formula is uv. So I will write x bracket e negative 2x over negative 2 with limits 0 to a minus integrate 0 to a v du dx. So e negative 2x over negative 2 dx. That will be my left hand side. And then the answer is equal to be 1 over 8. Now, for the left hand side, replace the x by a. So I will get ae negative 2a over negative 2 minus, when x is equal to 0, so everything is 0. Now for the second term, which is the integration, I will move out this negative 2 and combine with the minus. That means it becomes plus half. Then left the integration of e negative 2x. So integration of e negative 2x, which is our dv dx. So when integrate, that is our v. Then I will get e negative 2x over negative 2. From 0 to a, that equals to 1 over 8. Right? So now, the first term, rewrite ae negative 2a over negative 2. This minus 2 move out, becomes negative half. Negative 1 over 4. Sorry, negative 1 over 4. And then I will replace my x by a now. So I will get e negative 2a minus e0 equals to 1 over 8. So E0 is 1. Okay, so from here I'm getting E negative 2a over negative 2 minus 1 over 4 E2a. This is 1. Then minus 1 over 4 times minus 1 is plus 1 over 4. Then equals to 1 over 8. Okay, so now let's look at the question first. You need to show a is 1 over 2 ln of 4a plus 2. So by looking at the denominator, you have 8, you have 4, you have 2. The best way is just times the whole equation by 8. Right? So you times by 8. So when I times by 8, the first term is negative 4ae negative 2a. The second is negative 2e2a. Oh, sorry, there's a negative power here, negative, negative. And then the third term is going to be plus 2. And then last term is 1. Okay, so I have e negative 2a. So maybe I will just move it down first, then you can see clearly. So it will be negative 4a over e2a minus 2 over e2a. Then these two terms I can just simplify by moving the 2 to the right side. So it becomes minus 2 plus 1. So it will be minus 1. Okay, so from here, times whole equation by e to a. So I will get minus 4a minus 2 equals to minus e to a. And by looking at this equation, all are negative. So I times by negative. So it means that 4a plus 2 is e to a. Okay, times by negative. Or I would say negative 1. That would be better. Okay, now let's look at the question. What do you want to show? You see the 4a is over here. Okay, you have the ln half a. So it means that I need to group my 2a as one term first before I get the answer. So this is my e to a, right? I need the 2a one side, then the 4a plus 2 one side. So I already found the 4a plus 2. Means now I just need to take ln both sides. So ln e2a is basically 2a. Then my a is half ln of 4a plus 2. Okay, so we have shown the form. Right? Now, next is verify by calculation that a lies between 0.5 and 1. Okay, so I will rewrite my a first. A is half ln 4a plus 2. So to verify this, I'm going to use a sign change rule. Okay, so according to sign change rule, I need to rewrite my a minus a minus half ln 4a plus 2 equals to 0. As long as you get right side is 0, the left hand side will be the FA. So my FA is a minus half ln 4a plus 2. Then replace the a by these two values. Firstly, your a is 0.5, so I'll get 0.5 minus half ln 4 bracket 0.5 plus 2. Okay, and then this value is negative 0.193, which is less than 0. Now followed by F1. So f1 means 1 minus half ln 4 times 1 plus 2. Then this is going to be 0.104 and it is greater than 0. So you just write there is a sign change. Hence, A lies between 0.5 and 1. Okay, so every time when we need to verify the root lies between two values, then we are going to use this method, sign change rule. Okay, now see, use an iterative formula based on the equation in A to determine A equal to 2 decimal places. Give the results of each iteration to 4 decimal places. So now our A was 1 over 2 ln 4A plus 2. Okay, let's double check. A is half ln 4A plus 2. So this is the formula. But then when you need to apply the iteration method, right? So you need to add on the subscripts. So it means that now my A becomes AN. Then now my A on the left hand side is A with the subscript of n plus 1. This becomes the iterative formula. Now, since your A, just now we have proven that the A lies between 0.5 and 1. Now your initial A, which means the A naught, you can choose 0.5, 1 or any numbers in between the two values. So I will always choose a mid value, okay, the middle point of 0.5 and 1. That is 0.75. Alright, you are free to choose any initial A. So when A naught is 0.75, now my A1 is half of ln 4 brackets 0.75 plus 2, and the answer is 0.8047. So each iteration 4 decimal places. Now here final answer 2 decimal places. When to stop? You look at the last 2 digits. Make sure they are the same. So now we are going to use this A1 to get the A2. It will be half ln 4 bracket 0.8047 plus 2, and then you will get 0.8261. So H2 are not the same. Now continue for A3, half ln 4 bracket 0.8261 plus 2. Then it will be 0.8343. Again, not the same. So we have to proceed to A4. And now you are getting 0.8374. Okay, now look at the 2 decimal places. 83. They are the same. Final answer is based on the last one. So since the third digit is 7, it is more than 5 or 5 and above, therefore we round up. At last, our A is going to be 0.84. Okay, so this is how we get the how we decide the root using iterative formula. Okay, so now let's move on to question 10. The polynomial, this is a cubic polynomial, is denoted by px. A, show that x plus 3 is a factor of px. So first of all, I will write down px is the cubic function. Now to prove x plus 3 is a factor of px, we are using factor theorem. So factor theorem says that when x plus a is a factor of pa, is a factor of px, then p minus a is 0. How to get this minus a? Just let this be 0. Then your x will be minus a. So x plus 3 equals to 0, x equals to minus 3. So now I will replace x by minus 3, and my answer for this p negative 3 should be 0. So the first term is negative 27. Second term is plus 45. Then minus 93 plus 75. So when you get the total, it is 0, which means x plus 3 is a factor of px, according to factor theorem. Okay, so B, show that the z or z equals to negative 1 plus 2 root 6i is a root of pz equals to 0. So now just now was px. Okay, now you change the x to z. So I will write pz, just change accordingly. So it will be cube, then plus 5z squared, plus 31 z or z, plus 75. Okay, to prove that this is the root, what to do is, again, use the same method, right? If this is a root, means that p of this value will be 0 as well. So now just do the expansion. So p of minus 1 plus 2 root 6i equals to degree 3 of this root plus 5 brackets minus 1 plus 2 root 6i squared plus 31 minus 1 plus 2 root 6i plus 75. Okay, so for the first one, when you need to consider cube of this, right, and there are two terms, what to do is we can just use the Pascal triangle. So a plus b degree 0, coefficient is 1. A plus b degree 1, the coefficient for a and b will be 1, 1. Okay, if it is degree 2, it will be 1, 1, and then plus these two together in the middle, it becomes 2. So if this is degree 3, I will write 1, 1, front and back, plus together it will be 3, plus 2 and 1 will be 3. All these are the coefficients for the terms when this is cube. So which means I'll get minus 1 cube because the coefficient is 1 here. Then plus 3. Now, this expansion is same as the binomial expansion, means that you need to decrease the degree of first term and increase the second term degree by 1. So here, minus 1 squared, 2 square root 6i, degree 1. Then the next coefficient is 3. So 3 minus 1, degree 1, 2 square root 6i, degree 2. Lastly, the coefficient is 1. So 2 square root 6i, degree 3. Now, plus 5, this is a quadratic. Here a, here b. Right? So it will be a squared plus 2ab. So it becomes minus 1, 2 square root 6i plus, these two should be normal size, 2 square root 6i squared. That will be the quadratic expansion. Then here, just do expansion. I will get negative 31 minus 62 square root 6i plus 75. Okay, this is plus. Alright, so now further simplify all the terms. First term here, minus 1 cube is minus 1. 3 times minus 1 square is 3. 3 times 2 root 6 is 6 root 6i. Now be careful with this. This is I squared. Okay, I squared is minus 1. So here I will get positive. $72. Right? Now, when I square is minus 1, this is I cube. So I cube is I square times I, which means it's minus 1 times I, then you will get minus I. So next time is going to have I. So I will get negative. Cube of 2 root 6, you will be getting 48 root 6, then I. Okay, then here, just do expansion. Minus 1 squared is 1. 1 times 5 is 5. 2 times minus 1 times 2 root 6i will be negative 4 root 6i. Multiply by 5, it will be negative 20 root 6i. Then again, I square is minus 1. So I will write minus. Square of 2 root 6 is going to be 120. Okay, rewrite the other three terms. Then now, when you simplify, okay, look at here. Minus 1 plus 72 plus 5 minus 120 minus 31 plus 75, it will be 0. Okay, total will be 0. Same for the I. Those with the I, when you plus all together, it will be 0 as well. So at last, I get 0. So once you get 0, then we can say the z or z, negative minus 1 plus 2 root 6i is a root of pz or pz equals to 0. Okay, so done for this question. C, hence, find the complex numbers z or z, which are the roots of pz squared or pz squared equals to 0. Okay, let's check. Right. So now, from the previous questions, we know that if you change this x to z or z, I have found a root. You see, this is the first root. X equals to 3. X equals to minus 3 is the first root. Then, the second root is this complex number. Now, you just need to change this z or z to z squared, okay? Which means now I know that my pz squared equals to 0 means that my z squared is going to be minus 3 from the A, and then from the B, minus 1 plus 2 root I. 2 minus 1 plus 2 square root 6i. Now, another hint is you look at the polynomial itself. So by looking at the polynomial, all the coefficients are real numbers, which means the conjugate is another root. Okay, so the conjugate is going to be minus 1 minus 2 root 6i. But all these are for z squared or z squared. And now you need to find the z or just z, which means if z squared equals to minus 3, then the z is going to be plus minus square root minus 3. Then I will get plus minus square root 3i. That will be my z1 equals to root 3i. z2 is minus root 3i. Okay, I'm going to get 6z now because all these are z squared. So now, when z squared is negative 1 plus 2 root 6i, I need to get my z. So I will let my z be x plus iy. Then now replace x plus iy squared is minus 1 plus 2 square root 6i. Then do expansion. For the left hand side, x squared plus 2xyi plus y squared I squared. So I squared is minus 1. So I will just write minus y squared equals to minus 1 plus 2 root 6i. And now for the left hand side, I will group the real part. Okay, so x squared minus y squared is going to be minus 1. Then my imaginary part, 2xy, is going to be 2 square root 6. So now I need to solve these equations to get the x and y. So from the second part, I will just let my y be square root 6 over x. This is my first equation, and my y equals to square root 6 over y equals to square root 6 over x as the second equation. So I substitute second into first. I will get x squared minus square of this term equals to minus 1. Okay, so x squared minus square of square root 6 is 6. Then the bottom is x squared. Right, the denominator is going to be x squared. So times the whole equation by x squared, you will get x degree 4 minus 6 equals to negative x squared. and rearrange it to get a quadratic equation. Quadratic equation means in terms of x degree 4. Right? So now you can just do the factorization. Instead of x squared now becomes x degree 4. So my factorization will be x squared minus 2 times x squared plus 3 equals to 0. So from here, x squared minus 2 equals to 0, or x squared plus 3 equals to 0. So x squared plus 3 equals to 0 means x squared is minus 3. Remember, in your definition of the complex number, x and y must be real numbers. So x squared cannot be negative 3. That means this is undefined. Therefore, x squared is going to be 2. Then your x is plus minus square root 2. Okay, so now we found 2x. To get the y, you need to refer to second equation. Y equals to square root 6 over x. So from second equation, y equals to, I will just write x equals to square root 2 first. My y is square root 6 over x. So it's going to be square root 6 over 2, which is square root 3. Then when x goes to negative square root 2, my y is square root 6 over x. Right? So it is the same as previous, square root. So it will be negative square root 3. Alright, so now from here, I will get my z3 is, look at the definition, I define as x plus iy. So now my x3 is x, which is square root 2 plus square root 3i. Then my z4 is going to be negative root 2 minus root 3i. Okay, so I found 4 roots at this moment. I still have 2 more roots, means that when the z square is minus 1 minus 2 root 6i. Okay, so what to do is I will just do side by side here, so that because they are almost the same as the previous working. So when z square is negative 1 minus 2 root 6i, I let the z be x minus iy. Okay, why do I choose minus? Because here is minus. The imaginary is minus. So I will just follow. Alright, so then it will be the same. Just repeat all these steps. So x minus iy squared equals to minus 1 minus 2 root 6i. And now do expansion for this quadratic. It will be x squared minus 2xyi. Again, square of iy, it will be minus y squared. Okay, so now when I compare the real and imaginary parts, for the left hand side, real parts will be x squared minus y squared. Right hand side is minus 1. For the left hand side, the imaginary part minus 2xy, and the right hand side imaginary part is minus 2 square root 6. So from here, basically for the second equation here, the imaginary part, I will be getting the same equation as the previous working here. So I will get y equals to, because the minus 2 can be cancelled off. So cancel off. Then I will get y equals to square root 6 over x as well. So this is my third equation and fourth equation. Now, when you compare first, second, and third, fourth, they are exactly the same. Okay, first equals to third. Right? First equals to third. Then number 2 is same as number 4, which means, right, I will get the same solution. Okay, so my x is going to be plus minus 2. Plus minus square root 2. Okay, and then my x equals to square root 2. My y will be the same, exactly the same. My y will be square root 3. So when my x equals to negative square root 2, my y will be negative square root 3. Okay, It's just that my final answer will be different because look at here, I let my z be x minus iy. Just now was plus, now becomes minus. So therefore, I will find z5 is x minus iy. So it becomes square root 2 minus square root 3i. Then my z6 is minus square root 2 minus minus. So it's plus square root 3i. Okay, so final answer, roots of pz squared equals to 0. Z1 is, I will just rewrite all my final answers. Square root 3i, then negative square root 3i, this is my Z1. Z2 is negative square root 3i. Z3 is root 2 plus root 3i. Z4, negative root 2 minus root 3i. Z5, root 2 minus root 3i. Then last root is negative root 2 plus root 3i. Okay, these are my solutions for this question. Right? So with this, I have completed this paper, right? May-June 2003, paper 3.1. So thank you for watching. If you enjoy my video, watching my video, please subscribe to my YouTube channel, okay? And stay tuned for more upcoming videos. Thank you. Bye.